This lesson is going to focus on polynomial functions in standard form. Okay, standard form is a very useful form, especially as you advance through math, and in calculus you'll use it to find max and mins, points of inflection. But in algebra 2 it does have some limitations, but it does tell us a lot about the graph of a polynomial function. From standard form, we'll be able to identify the end behaviors, right? The left end behavior, the right end behavior, if they're going up or down towards infinity or negative infinity. We'll be able to tell the maximum number of x-intercepts. Okay, we won't know how many exactly, but we know the most number of x-intercepts there could be, and actually the fewest as well. And we'll be able to know the maximum number of extrema. How many times is the graph going to turn? How many mins and maxes are possible for the graph? And then standard form always is easy to identify the y-intercept in. So we're going to study some graphs and look at some key features that are given to us, and then see if we can make connections to everything. All right, so we have this first graph here. And so we want to be able to identify the degree, the leading coefficients, and see if we can make connections between them and the graph. So we have this in standard form. The highest exponent is 4, so the degree is 4. All right, and so is that an even or odd number? Okay, so this is an even degree. All right, and we're gonna make connections between the number 4 and the fact that it's even. Okay, number of x-intercepts. Okay, just go ahead and count them. 1, 2, 3, 4. Okay. Number of turns. So there's one minimum, then a maximum, and then a minimum. So it turns 3 times. Okay, the leading coefficient, what number is in front of the first term? And that's just a 1, right? And that is positive. Okay. The right end behavior, so go back a few weeks. So you write right end behavior. So as x approaches infinity, what is y approaching? And so the right side of the graph, okay, what's y is going up forever. So y is approaching infinity. Okay, the left end behavior, so as x approaches negative infinity, what is y approaching? And y is also approaching infinity. So you can see that they're approaching the same. They're both going up. Okay, and what's the y-intercept here? The y-intercept here is 0, 1. Okay, so we're just making observations right now. Okay, I could have also asked you the domain and the range. When is this increasing? When is this decreasing? Okay, but I'm really trying to make a connection between the degree and the leading coefficients and how they relate to the end behavior. So we have to look at more than just one graph to determine this. So we're going to focus on a total of 4 graphs and then have a discussion. All right, so here's our second graph. Negative x squared plus 2x plus 3. So this is just a quadratic. It's something that we're used to doing in standard form here. So the degree, the highest exponent is 2. That's an even number. Number of x-intercepts here are 2. Number of turns is only 1 turn. Okay, so here this one had 4 x-intercepts and 3 turns. This had 2 and 1. What kind of connection is that? The leading coefficient here is negative 1. That's negative. The right end behavior is negative infinity, and the left end behavior is negative infinity. All right, so I'm just going to write the y part for the sake of time. Y is going towards negative infinity for the right, okay, and for the left. Well, let's just write it all out. As x approaches positive infinity, so that's the right end behavior, y is going down. And again, as x approaches negative infinity, so the left end behavior, y is also going down. And here the y-intercept is 3. So the point 0, 3. All right, so on both of these graphs, okay, they are even degrees. One's a 4th degree, one's a 2nd degree. All right, what do they have in common? Both end behaviors are going the same direction in both graphs. Now both are going down and the other one is both going up. So what do they have that's different is that the leading coefficient was positive on the one that was both going up, and the leading coefficient was negative on the one that was both going down. All right. What do we notice about the x-intercepts? X-intercepts matches the degree. There's 4 x-intercepts when the degree is 4. Okay. And then there are 2 when the degree was 2. All right. But I mean, is it always 4? Could I have more? Could I have less? Okay. It's something we'll talk about a little bit later on. All right, so now same thing, same questions. We've got 2 new graphs on this slide. Okay, here the degree is 3. That is odd. Number of x-intercepts, 1, 2, 3. Degree x-intercepts, same as last bit. Number of turns, 1, 2. Still 1 less than the number of x-intercepts. Leading coefficient here is 1, that's positive. Okay, here the end behaviors are going in different directions. So the right end behavior, okay, so as x approaches infinity, what is y doing? Y is approaching infinity. The left end behavior, so as x approaches negative infinity, in this case, y is approaching negative infinity. Okay, so now the end behaviors are opposite. Okay, so do they still connect to the leading coefficient like the even ones did? Okay, so as x gets really big, what is y doing? It's getting big because the a tells us it's positive, it's growing. Let's see what happens with the negative one. Okay, so here we got a degree of 5. It is odd. Number of x-intercepts, 1, 2, 3, 4, 5. Number of turns, 1, 2, 3, 4. Again, degree is the same as x-intercepts. Turns is 1 less. Okay, leading coefficient here is negative 1/2. So that's negative. Now here the right hand behavior. So as x approaches positive infinity, on the right side, now y is going down. Okay, does that have something to do with that leading coefficient? Right, our a, okay, telling us direction. So as x is really big, it should match what our a is doing. Okay, left hand behavior. So as x approaches negative infinity, okay, here it is getting very big. So our left end behavior is the opposite, okay, and that's positive infinity. The y-intercept here is 0, 0. Okay, and it looks like I forgot to do that on the top one here. Here the y-intercept was negative 2, 0, negative 2. Okay, and how do those relate to the graph or the equation of the graph, really? All right, so now let's see if we can't make all these connections here. I've got some questions here. We'll look back at the slides if we have to. What do you notice about the degree of the function and the number of x-intercepts? So the degree was 4, the number of x-intercepts was 4. The degree was 2, the number of x-intercepts was 2. The degree is 3, number of x-intercepts 3. The degree is 5, number of x-intercepts. It matches, okay? But what if I shifted this graph down, okay? And so it was down, and that one doesn't come all the way up, and then now it would only have 2. Or what if I shifted it up? And now the graph would have none. So this graph does have 4. That's the most it could have. But it could have 2. It could have 0. Okay, so I can make this graph have 1 if just that min was on there. So there's different numbers, but the most it could have seems to match. Okay, so let's type that in there. Okay, so I notice that the degree matches maximum number of x-intercepts. They don't always have to match, but the most it could have will match the degree. Okay, what do you notice about the degree of the function and the number of relative extrema? So if you noticed, right? The degree was always 1 less, okay, than the number of turns. And that should make sense, because if the max number of Extrema, the X-Intercepts means it's changing direction through there, and the Extrema matches change of direction. So there's only 1 less. Okay, so and I notice that degree, okay, well, in this case, when I say it like this, the degree is always 1 more than the number of turns. I often also say it the other way. The number of turns is 1 less than the degree. Okay, so I'll type that in 2. The number of turns is 1 less than the degree. And again, this is the maximum number of turns. There doesn't have to be that many turns. That's the most number of turns there could be. So if the degree was 10, the most number of turns could be 9. All right, whoops. Okay, now what do you notice about the end behaviors when the degree is even versus odd? So on even, we notice that they were both going up or they were both going down. The end behaviors were going the same direction. And we noticed when it was odd, one was going up, one was going down, so they were going in opposite direction. All right, so when the degree is even, I noticed that the end behaviors same. When the degree is odd, the end behaviors in opposite directions. Okay, and then the last question here, what do you notice about the right end behavior when the leading coefficient is positive? What do you notice about the leading coefficient when it is negative? Okay, so here it's positive, the right end behavior was positive. Here it was negative, and the right end behavior was negative infinity. Right? Even on the odds, when the leading coefficient was positive, the right end behavior was positive. And when the leading coefficient was negative, the right end behavior was negative. So the connection here is the leading coefficient, okay, the sign of the leading coefficient is very important. Okay, so when the leading coefficient is positive, right end behavior is positive infinity. When the leading coefficient is negative, right end behavior is negative infinity. All right, and so, well, the left end behavior is just going to depend if it's even or odd then. Right? If it's even, the left end behavior will match the right end behavior. Right? If the degree is odd and the leading coefficient negative, right, then the right end behavior is negative infinity. The left has to be opposite, so the left end behavior would be positive infinity. So it all depends, on 2 things: the degree, if the degree is even or odd, and if the leading coefficient is positive or negative. That's going to tell you your end behaviors. Right? And then the y-intercept, okay, was always, I didn't ask the question on there, but was always just your constant, that last term. 1, 1, 3, 3, -2, -2. There is no constant, it's 0, so 0, 0.